This is our first video to do with the assignment. Critical maths in the middle of the assignment is the ability to connect two quadratics, or any two functions, but in this case we'll choose quadratics, connecting them up in such a way that the gradient of the first one just naturally goes into the gradient of the second one, so there's no bump. If you're on a roller coaster, you wouldn't notice a speed bump. If you're running a finger along the function, you wouldn't notice any bump between the two. The first quadratic, you basically need to make something up. If you're completely starting the assignment from fresh, just make up your first quadratic. Probably something like y equals x squared is not a bad start, but you'll find it probably goes a little bit high. It needs to, you need to balance and make some judgments about whether you need an a value in front of that x squared. But having just assumed it's y equals x squared, we're going to generate another function that sits behind that one or sits next to it, and that'll be in the form y equals ax squared plus bx plus c. The a, b and c values are absolutely critical to this process. They're the ones we're actually going to be finding. We do this with three different equations or three different formulas. We know three things, okay? And the first thing we know is that the two functions have a point in common. This means that you can select a point where you want the join to occur, and it has to be on both the first function, and that point also will be on the second function. That allows us to substitute in and get an expression that has a, b and c in it, and that the fact that we've used there is that the first point is known. The next thing we're going to do is look at the gradients. The gradient where the two functions join is known because you know the first function, you know the derivative of the first function, and you know the x value. So you should be able to find m of the joining point. We simply force that gradient, okay, to work for the second equation. And again, you'll have an a and a b. You probably won't have a c, but you'll have an a and a b value for that particular simultaneous equation. And then the third one we do is we pick a point somewhere in the future where we nominate it, and we say I'd like my second function to pass through this point. At this point in time, we're now working on the first function, the critical point being we're really interested over here in the point 39 and the fact that this second curve passes through that point. And if you substitute your values for x and y in, you should get yourself an expression that has a, b and c in it. We call that equation number one, okay, and that really resolves this issue. We know something. We know that this function y equals ax squared plus bx plus c passes through 3, 9. So you force the 3 and the 9 in there, and you're left with a's and b's and c's. Don't stress, because we're going to have more information that will allow us to find a, b and c later on. The second equation that you're working on is the fact that at 3, 9 we're expecting to know what the gradient is, and that's because fortunately we've got a y equals x squared as our function. Now if your first function was y equals half x squared, you'd still find the derivative and you'd be able to substitute x equals 0 in and allow yourselves to work out what the gradient was. So that gradient is not just the gradient at 3, 9 for the first curve, it's the gradient for the second curve, because they're going to have exactly the same gradient. So what that allows us to do is, having taken the derivative of the second function, we substitute in x equals 3, but we don't know what a and b are, but we do know that the gradient has to be 6. So you get that expression there. That's your second function. That's the second important piece of information. So you can see we've got the first one up there in blue, which is our first simultaneous equation. We've got a second one here. All we need to do now is find the third one and then go ahead and solve. The final important piece of information, the three facts that we need to use, is that this point has to pass through, or the function needs to pass through 7, 10. Now that's been chosen arbitrarily or randomly, but it nevertheless shows you how the process works. We are again mentioning the fact that this unknown function, y equals ax squared plus bx plus c, is going to be passing through 7, 10. So we substitute 7. Okay, you see sitting there next to the b, and 7 squared sitting next to the a, and the 10 sitting there. And we'll get ourselves a third function. What that means is overall now we're going to have these 3 functions here. These are the 3 functions which we've determined. Now, in a separate little video, I'll talk about how we solve these simultaneous equations. But for now, just to wrap it all up, okay, to give you some idea of what this all means, we've got this final sketch down the bottom. So, we've got a function, y equals x squared, that runs through here, and we've got a function, y equals ax squared plus bx plus c, that runs along there. We've got a point of intersection here, which we identified and called 3, 9, and that point is common to both, and the gradient of each curve is 6 in this case here. What it means is then, is that having solved the simultaneous equations and found all these 3 values for a, b and c, which a, b and c are there, we can generate, by just substituting a, b and c in, a new quadratic. This one doesn't mention y and x because it's a general form. We've now found ourselves that if you were to make those 3 values, a, b and c, graph it, all things being good, the 2 functions would overlap perfectly. The only physical constraint to the overlap is that you're working to 3 or 4 decimal places. Please don't go past that. There's no need. You will always be able to zoom in maybe to a ridiculous level and see that there's a slight mismatch between the curves. That's literally because you're looking at the 4th decimal place, so it's not worth it. So if you're struggling to work out how to solve the 3 simultaneous equations that I mentioned up here, then look at this next video or another video. Thank you. Enjoy your weekend.